All right, Tigers, here we go. Podcast Thursday, 16th. We're going to start doing cross-price elasticity today. A little bit of practice just to make sure we're clear on some of these things. Here's the warm-up. It will be posted as soon as Mr. Joel gets it to me. And here will be what we're going to do. Here's where the podcast will be loaded right here in case you guys need anything to that point. So, without further ado, a total revenue practice problem. All the Buckeyes. So Lucy Lugnut and her boyfriend Diesel make metal bumper stickers that buyers could bolt to their bumpers or hang from their gun racks. And the bumper sticker said, "Oh, go Buckeyes." So the question is, if I'm giving you price and quantity, can you calculate total revenue? And then using price and total revenue, can you do the total revenue test at that point? So I'm going to pause here, and we should fill in the chart. Okay, and then we'll answer questions 2 and 3. 3, 2, 1, go. Looking at this going forward here, here's the total revenues to that point. So the price from here to here is always going up. So we're going to say that price goes up, total revenue is here. So price goes up, total revenue goes up. Inelastic. Okay? Inelastic. Inelastic. The price is still going up, and so is the total revenue. Inelastic. Inelastic. Inelastic, right? Inelastic. Now it changes because the first time here the price goes up and the revenue goes down. So elastic, elastic, elastic. At that point, sorry, I moved it over a little bit. Okay? Yeah, I know this should be, some of you math gurus out there, it should be like 0.50, but I just rounded it off, okay? So would you advise this couple to raise the price of their bumper stickers to $3 even though they would sell yes? So here's $3, right? Raise the price to $3. It's still on the inelastic side of the curve, guys. So when price goes up and total revenue goes up, yeah, you should raise the price. So the answer to this question here, when price goes up, and total revenue goes up, it's inelastic, and we already told you this, and this is one of the main points of the lesson, guys. When you have an inelastic elasticity demand, there's always a reason to raise prices, and you should at that point. Would you advise to this couple to raise the price of their bumper stickers to $2 in an effort to sell more? Okay, this shouldn't say raise them, should lower. Okay, to sell more. And the answer is no, because if I go from 3 to 2, price is going down. Okay, total revenue is going down. That's inelastic. I don't want to raise price. I don't want to lower prices. I want to raise prices. The question is, where should I end? Right? If price is going down, right? Price is going down and total revenue is going down. I don't want to do that. I want to raise my price. So the question is, how far do I go? And it's going to be somewhere between $4.50 and $5. Now, the math tells you total revenue-wise, we want to be at about $4.50. Why? Because at $4.50, that's where we know that we are revenue maximizing. We don't know if we're profit maximizing yet. We'll get to that later, okay? But we're revenue maximizing. Okay, let's switch on to this problem, okay? Here we go. Again, total revenue test, and then an elasticity question, right? All right, so Kenny would raise his prices from $30 to $35 for a ticket, okay? So we know that, right there. We know that prices are going up, okay? And the number of people going to Kennywood falls from 5,000 per day to 4,500 per day. Is the demand for Kennywood tickets elastic, inelastic, or inelastic? Okay, well, okay, what do we got to do? We got to do a little bit of a math problem, right? So, 30 times 5,000 equals, right? And 35 times 4,500. Oops. Okay, I'm going to get my calculator out. 3, 2, 1, stop. All right, so looking at my math here, 150,000. When you raise the price, your total revenue is 157,000. So when they're both pointing the same way, we are inelastic at that point, between 30 and 35. So technically, we should probably raise our price a little bit higher to see where we are. Okay, next question. Suppose the coefficient of price elasticity demand for apples is 1.5. If a seller raises price of apples from 1 to 125, what will happen to this? Okay, good question here, right? We know that the price elasticity demand is 1.5, right? Here it is. right? So we know that we're on the elastic section of the curve, right? Okay, so what does that mean? If we raise the price and we're on the elastic section of the curve, what's going to happen? Are we going to sell more apples or less apples when you raise the price? Okay, the answer to me is pretty darn simple here, okay, right? You're going to sell less apples, right? What's going to happen to your total revenue? It's going to go down because you're selling less apples at a higher price, and it's going to fall off the marble because we know that since we're here, there's no reason to raise price. We know we're on that part of the graph, which is a hump like this at that point, okay? So the lesson for today focuses on this point here, this idea of cross price, okay? Cross price, guys, tells us how sensitive a product is to a change in the price of another good. So what cross price does, guys, is it mathematically tells us if goods are complements or if they're substitutes, okay? So cross price, it's labeled XED, cross elasticity demand. You take the percentage change in quantity of product B, so for in this example, it's bike helmets, over the percentage change in price of product A, which in this case is bikes. So when I do the simple math problem, guys, I get negative. Now, this is the time it's important that you you keep your signs. Before, the positive and negative didn't really matter. Here, it's a little bit bigger of a bigger deal at this point. So you put 15 over 20, guys. You know that that answer is going to equal, okay, equal 0.75. It's 3/4, but it's not just 0.75, but it's negative 0.75, okay? If the coefficient is negative, okay, meaning that the goods, there's an inverse relationship between the goods. What does that mean? It means that the goods are complements. Okay? That's what it means at the time. If it's positive, substitutes. You guys see that these numbers are negative, right? Negative 0.75. So they go together. Bikes and bikes helmets go together. It should make sense at that point, right? So here I have 3 problems. I'm going to see you try at that point. Okay, and I'm going to talk you through these 2 different types here. If the cross-price elasticity of demand between peanut, butter, and milk is negative, then peanut butter and milk are substitutes or complements. Well, you're not going to, come on now, you can think this one through a little bit, right? You're not going to substitute those two, but the key is that it's negative. The cross-price elasticity is negative, okay? So we know for a fact that they're complements, right? Because a negative XED. Okay. So let's try and do this one over here. If the price of movie tickets increases from 10 to 12 and the demand of popcorn falls from 100 to 700. Okay, this should be pretty easy here now, okay? Remember our way to calculate elasticity of demand, right? You're taking the quantity of product B over the price of product A. The quantity of product B over the price of A. The quantity of product B over the price of A. Now, the way, remember, to determine percentage is to go new minus old over the old, okay, for both things here. So, for instance, for popcorn here, you would go, if I write this over here at this point here, I'm going to make it a little bit smaller because it's a little bit too big for me, right? I would go, the new is 700 minus, okay, 1,000 over, okay, 1,000. Okay, right? And that will give me my percentage change at that point. Where right below it would be the new is 12 minus 10 over 10, right? So make sure we're clear on that point. All right, so here we go. I laid some of this out for you. I did make an adjustment, by the way, because my math wasn't going to work out. So I made the Pepsi or the Coke cans from 3 to 4 at that point, okay? So what do I get here? I get, on the top here, 0.30. Is she working here? Get 0.30 divided by 0.20, and whenever I figure those out, I get, okay, so what I get is negative 1.5. So I know that if it's negative, that popcorn and movie tickets, I know, are complements, right? And they're sort of on the elastic side here. Right? This is closer to unit elastic. If I go down here, the difference between these two is it's 1, because 2 minus 1 is 1 over 1, right? It's 1 over what turns out to be 0.33, and whenever I divide those two at that point, guys, what do I get? I get 3, but it's positive, so I know that a positive number means that those two are substitutes at that point, right? And hopefully you get to see where I was coming from in that realm, okay? One more set of practice, make sure we have it, okay? Cross price of oil and coal, okay? To tell if there's substitutes or complements, and tennis rackets and tennis balls. Okay, I'll give you a second. I did the work for you to help you out a little bit, right? New minus the old over the old, new minus the old over the old, right? 0.1 over 0.3, 0.33. So we know, right, that since it's positive, right, since it's positive, let's make sure we're clear here, right, it's substitutes. And we think that oil and coal are substitutes, right? So if you can do the math and figure that out, we're there. And we know that since it's low on this point, we know that it's pretty inelastic, okay, in that realm. We pull that out that way. Negative 1.875, negative number, we know they're complements, right, tennis rackets and tennis balls, and we know that they're a little more on the elastic side with what comes to that point, okay? Hopefully this helps. You guys, some math here that you have to do the practice with, and I'm going to put a practice study guide together to sort of help you guys out and see how it goes. So I wish you nothing but the best. Have a great night, and we'll see you soon. Go Tigers.